Oh, hi. You interrupted me. I was doing a calculation. I was trying to figure out how long it would take the black hole in the center of our galaxy to evaporate. I was kind of worried about that. Turns out it's a trillion years, so I was getting worried, but it's actually not a big deal. Well, welcome. Size of the universe, take one. So how big is the universe? Well, to do this, we're going to have a scale model. We'll start with the scale model Earth. Here's the Earth shrunk to about 2 centimeters. That's 10 million times smaller than it really is. So we'll make a little scale model, 1 in 10 million, and see where that takes the solar system. Here's the Earth. We need a moon. Moon's about 4 times smaller. I think I have a moon. This will do. Okay, so there's the Earth-Moon distance, shrunk by a factor of 10 million. And that's as far as we've gone as humans, with spacecraft and astronauts. 40 years ago, in fact, cost $50 million, and we haven't been back for 4 decades. That's as far as our technology has taken us, but that's a small fraction of the size of the solar system. Actually, 10 million is an interesting number, because if you were an evil alien genius and you crushed the Earth to 2 centimeters, it would turn into a black hole. But we're not nearly at the scale of the solar system even. To see the rest of it, I'm going to have to go out of this room. Man, solar system is big. I went about 100 meters and I found this 3-meter yellow globe. I presume that's the sun. And then I started looking for the planets. I think I found Mercury and Venus, but I had gone halfway across campus. And then I sort of got lost. I think I turned right at Saturn. I found this little derelict rock with a condemned sign on it. That must have been Pluto. But basically, I was all over the place. And that was just the solar system. If I'd wanted to get to the nearest star in this scale model, 1 in 10 million, I'd have had to have gone 30,000 miles. So let's take our second step in the scale model. This time a factor of 100 million, shrinking from the previous step. So our solar system has gone down to the size of a grain of sand. Now that's not the sun. The sun will be a tiny, invisible mote of dust at the middle of the grain of sand. The grain of sand is the full extent of all the planet orbits, maybe even out to the comet cloud. That's a solar system, and we've now shrunk another 100 million from our previous scale model. Well, where's the rest of the universe in this scale model? So that's one star. Well, here's the next nearest star, 5 or 10 meters away. 2 grains of sand in a volume the size of this room. Space is pretty darn empty. And how big is the Milky Way, our own galaxy, on this scale model? Well, with about 1 or 2 grains of sand per room-sized volume, the Milky Way would be the size of the United States, and it would have several 100 billion stars, grains of sand separated by 10 meters or so each. That's pretty big. We're still only looking at one galaxy, yet another reduction in our 3-stage scale model. In our third step, we also reduce another factor of 100 million. Now a galaxy comes into view. Here it is, the Milky Way. It contains several 100 billion stars. The grains of sand no longer visible. You couldn't star here. But here's an entire galaxy, 100,000 light years across. But of course the universe has a lot of galaxies. Where would we have to go to find the nearest galaxy? There it is, Andromeda. well, it's an ammonite, really, but we'll call it Andromeda, M31, the nearest neighbor galaxy to the Milky Way. And in a volume like this room, there'll be a couple of galaxies. So we have two galaxies in a volume the size of this room, us and our nearest neighbor Andromeda. The observable universe is once again about the size of the United States, and it's filled with 100 billion galaxies. That's just the observable universe. Cosmologists had the idea that space and time goes far beyond what we can see with our telescopes. And don't even get me started about the multiverse. So there it is, the universe in a nutshell. We've used a three-step scale model, reducing by 23 orders of magnitude. That's a scale model shrunk by a factor of 100,000 billion. Darn, the universe is big. Astronomers actually run out of words for describing it, so they reduce to technical language like huge, immense, hugely huge, enormously big. It's really beyond comprehension. It's exhausting thinking about how big the universe is. I kind of need a pick-me-up. Luckily, I have some dark energy here, my favorite drink. It causes the cosmic expansion to accelerate as well. Well, that's all for today. I hope you got a sense of how big the universe really is.